Today I am going to teach you one application of Euclid's division lemma. Okay, two problems I am going to teach you. In my previous lesson I have explained you the general form of a even number and odd number, that you have to remember to do this. Okay, now I am going to explain in this class two examples which are very useful. Okay, let us go to the examples. So the first example is, show that any positive integer, I will write here any positive odd integer, any positive odd integer is of the form 4q plus 1 and 4q plus 3, where q is any integer. Okay, this is the question. Now 4q plus 1, 4q plus 3 is the form of a odd integer, that what we have to prove now. So this 4q plus 1 and 4q plus 3 is always an odd integer for any q. Q is an integer. Okay, q is any integer. So now here, if you understand 4q plus 1, it is in the form of a EDL, Euclid's division lemma. Okay, q is quotient, 1 is remainder, 4 is now. So here let us say, let us bring a formula in this. Okay, let us assume a. Let a is any positive integer. Let a be any positive integer. So now a divided by, then a divided by 4. That means because 4 is here, so let us take 4. 4 is the divisor position, divisor position mein hai, so 4. So if a is divided by 4, then by EDL, Euclid's division lemma, so then what happened, a is equal to, the dividend is equal to divisor into, let us say, quotient plus remainder. This is the division lemma rule. Okay, so what is R? Where what is R? R is always less than 4 and more than 0. So that 0, 1, 2, 3. Less than or equal to 4 and more than or equal to 0. So the possibilities of remainder is 0, 1, 2, 3. Only 4 values are there. The remainders can be only any one of these 4 values, 0, 1, 2, 3. Okay, because if it is 4, it is a divisor, so it cannot be 4, so it cannot be less than 0. So now let us have R is equal to 0, because 4q plus 1, 4q plus 3, R is 1 and 3 are the remainders. So let us understand this a when R is equal to 0. When R is equal to 0, then what happened to a? It is equal to 4q only. So 4q means, let us say 2 into 2q. So 2q is some integer, q is integer, 2q is also integer. Because it is multiplied by 2, therefore it is even number. Because this definition we have got it from the previous question. 2 into something is always even number. So at R is equal to 0, then what happened to a? A is an even number. Let us say at R is equal to 1. So then what happened to a? 4q plus 1. So let us see, let us try to write this in the form of a general form of a even number. Sorry, so 2 into 2q, this is even plus 1. That means this is even, you can plus 1, because this 4q is also already even. So this entire thing also will become even. Even plus 1 That means even number, if you add 1, it will become odd number. So at r is equal to 1, a is an odd number. Similarly, at r is equal to 2. So then what happened? A is equal to 4q plus 2. So then I can take 2 common. So 2 into 2q plus 1. So 2q plus 1 is an integer, whether it is odd or even. That is multiplied by 2. So it is always even number. It is yesterday's definition. Okay. So now at a is equal to r is equal to 2, we got a is equal to even. Let us say at r is equal to 3, because we have taken 0, 1, 2 and 3. So a, what happens to a? It is 4q plus 3. Let us write 4q plus 2 plus 1. Why 4q plus 2? Already we have written as a even integer. So then what happened? This is even integer. Even plus 1 is equal to odd. So that means it is odd only in two cases, at r is equal to 1 and at r is equal to 3. So at r is equal to 1, what is the form of a? 4q plus 1. At r is equal to 3, what is the form of a? Because we have assumed 4q plus 1. Therefore 4q plus 1 are, both are odd integers formula, or 4q plus 3 are always odd, and they are in the form of odd number. Okay, odd numbers are in the form of, because it is given odd numbers are in the form of 4q. So therefore the odd number you can write like this also. Odd numbers are in the form of 4q plus 1 or 4q plus 3. So this is more appropriate than this. Okay, so I hope you have understood. So here it is given square of any positive integer, either in the form of 3m or 3m plus 1. Here 3 is there, the divisor is 3. In the previous question 4q plus 1 is there, 4 is the divisor. Here 3 is the divisor. You should be able to understand the divisor. So here also let a be an integer. So then what happened? If a is divided by 3, a is divided by 3, because 3 is their divisor here, then by ADL, so then what you get? A is equal to divisor into quotient plus remainder. Divisor into quotient plus remainder. Q is the quotient. Q is the quotient. So here what is the R possibilities? The divisor is 3, it should be less than or equal to 3, it should be greater than or equal to 0. So R possibilities are 0, 1, 2. So let us check a square, because we want the square of this positive integer. We have taken a as an integer, we have to find out square. So now at R is equal to 0, then a is equal to what happened? It is equal to 3q. So then what happened to a square? A square is equal to 3q whole square is equal to 9q square. So 9q square I can write in the form of, I have to write 3 in the form of 3m, 3 into 3q square. So 3q square is an integer. 3q square is an integer. Okay, so here m is also an integer. So m is integer, 3q square is integer. Therefore, at r is equal to 0, we have got the square of this a is 3m. It is integer. Okay, let us say r is equal to 1. So then what happened? A is equal to 3q plus 1. Then a square, what happens? 3q plus 1 whole square. It is equal to a plus b whole square formula. So I will write directly 9q square a square 2ab 6q plus 1. So this is a 9q square plus 6q plus 1. So then how we are going to write this? Okay, 1 you keep it like this, 1 only. These two I can take 3 common, 3 into 3q square plus 2q. So now this 3q square plus 2q is an integer. 3 is into integer I can write plus 1. So integer I can write m. So I can write 3m plus 1. So it is also an integer. So similarly you can write r is equal to 2 also. That means you do any one of these three reminders, you should be able to put that a square either in the form of 3m or either in the form of 3m plus 1. So let us see whether we can write at r is equal to 2 in the same form or not. So a is equal to 3q plus 2. Now a square we want. A square is equal to 3q plus 2 whole square. Let us again a plus b whole square. So 9q square plus 2 3 is 6 2 is 12q plus 4. So then whether we can write this in the form of 3q plus 2 whole square or not, that we have to check it out. Okay, so that means we should write in the form of okay, now what I can do it, 9q square plus 12q plus 3 plus 1 I will write. Okay, 4 I have written, 3 plus 1. So that what happened, in this I can take 3 common, 3q square plus 4q plus 1 plus 1. So this entire thing is an integer. Because q is integer, everything is an integer. Whether it is odd or not, it is not given. So then what happened, it is again 3m plus 1. So that means at all the 3 values of r, a, that means a square, the square of a is in the form of 3m or 3m plus 1. Okay, so you have to do this 3-4 times, so that what happened, that concept will go into your mind. I hope these 2 examples are okay on EDL. Tomorrow we will take the another concept.